could probably fit, I don't know, another 10, 12 of these then just in this little space.
Yeah, well, I think it's around 10 machines to 80 square metres, so it's a very high output from that machine, that floor space.
So you're talking about a real density of engineering capacity.
Yeah, I mean, if you look at this machine and compare it to an alternative brand, then you could potentially get 2 machines in the same footprint as the single spindle machine.
We're here at the Tornos factory in Switzerland. I'm here with David Dunn from Premier Machine Tools, who supply these wonderful machines in the UK and Ireland. But we're going to be reviewing the Swissnano 10, which is your brand new machine. Let's have a quick look inside. It's an impressive looking machine, but it's in quite a compact space. What kind of parts would you make on this?
So the Swissnano 10 is a development of the existing Swissnano range, so the 4 and the 7. This gives you a slightly bigger bar capacity and obviously also a longer headstock stroke. So it's really looking at micromechanics, but it could be aerospace, could be automotive, could be medical as well. So lots of different market segments.
And when people think sliding head machines, they normally think there's a lot of round features, but it's not just round features now you're doing. There's a lot of different complex features you can do on these parts in one hit on this machine.
Yeah, with the Nano 7 and the Nano 10, we have a lot more driven tool capability in the main operations and in counter operations. So we have the possibility for gear hobbing, thread whirling, polygon turning, and so on.
So the options for being able to do one part in one hit, complete on this one machine is endless. Can we just discuss actually what the options are for the different configurations here? You've got lots of different tool posts available and lots of different areas where you can fit driven tooling. Why do you need all these different options?
To suit the component that you want to make, really. So with this, this is really a stripped out version that we've got here. So we can have on the main platen here, we can have either all turning tools, we can have a shorter plate that we see here, and then we can have up to 3 driven tools. So you can have your thread whirling, thread milling, gear hobbing, and so on. And then we have counter spindle and end working positions down here. So again, we can have stationary tools, or we can have driven tools there, high frequency spindles for an example. And then in counter operations, we have 4 positions as standard, but we can change those out for either stationary, or we can have driven tools in there as well, up to 2 in counter operations for linear and tangential.
So they're very generalist in that you could put any kind of configuration of tools you want, but once you do that, it then becomes a specialist machine just for that one part, and that means you can shave off every piece of cycle time that you need to achieve. What kind of volumes will people be achieving with these machines?
I mean, they can be very low batch numbers, but equally they can be very high volume as well. And one of the things with the Nano products is the way they've been designed enables you to put a lot of machines into a very small footprint. So you're maximising the output from that square footage because of the design and the access to the machine as it's required.
Yeah, you look at this machine from afar and you think, well, there's not much here, is there? But the amount of engineering knowledge that's gone into this is very impressive. And I guess people know the 4 and the 7 for their thermal stability, their rigidity. What has been carried over in the design that allows you to still sell that Tornos, that Swissnano rigidity and stability? It's
really the design of the casting, and that's a main
Let's come around and have a quick look at the casting. It's just around here.
So it's a main feature of the machine really is the symmetrical casting. So the thermal expansion of the machine is very linear and very stable. There's a lot of work been put into the casting to circulate air around the casting to give the stability, and that gives the machine obviously improved accuracy as well.
Yeah, because I guess when you're running these things lights out 24/7, as many people do, the utilisation of these machines is up in the 90% range.
Yeah.
You need to make sure that at 3 o'clock in the morning when it's, I don't know, when the machine's been running for 24 hours and it doesn't get too hot and make bad parts, because you could have thousands of parts in that basket and you want them all to be bang on and correct, don't you?
Yeah, exactly, yeah. And you know, the thermal stability, if you look at the Nano 4, Tornos have had experienced manufacturing parts on there holding tolerances of plus or minus 1 micron. So they are very stable and very consistent in production.
And what about the controls on these machines? Are they easy to use?
Yeah, so these are standard FANUC controls, so twin channel programming, ISO command, so a conventional control that people will be used to.
So you can synchronize both spindles and it's really easy to set. One program one side, one program the other side.
Yeah, exactly. And you can program obviously directly on the machine, or you can program with the Tyson software from Tornos.
Oh, okay. So if you're pumping out all of these parts, obviously you're cutting some material. How do you do the swarf evacuation and how do you do the swarf management?
So the swarf management is generally on a basic machine is through the front here. But on the Nano 10, we can have the option of a swarf conveyor as well. So that takes the swarf through the machine, under the machine, and out the back to again maximise the output from the floor space. So we're not adding a conveyor that takes up additional floor space.
Yeah, so the swarf conveyor back here actually it goes under the bar feeder, which
exactly,
is it's wasted space because that bar
Yeah.
feeder's sat up here on centre. You've got all this space under here
Yeah.
you're not using. So
Even down to on this machine, the conventional coolant setup, the coolant tank goes under the machine. So again, we need a bigger coolant capacity, we need high pressure coolant, for example, and it's all stored under the bar feeder, so utilising the floor space properly.
And that high pressure coolant makes sure you're reducing your tool wear, meaning you don't have to have as much sister tooling, get a better swarf evacuation as well, so you can make sure that those parts are cut as easily as possible
Yes,
as well.
absolutely. Yeah.
Okay, let's talk about the working area now. So
Okay.
I guess you see quite a lot of sliding head shops will have a machine after machine after machine all in a line just so they can achieve the different the 10 different parts, but in the ridiculous volumes. They need them all running as
Yep.
quick as possible. So where would the operator be working this machine, and how does that allow you to maximise your floor space?
So with the Nano 4, Nano 7 and Nano 10, the design of the machines is primarily the same. So we have access to the work area from the front here, but also from the side, to the headstock, and the FANUC control is all from the side of the machine. So that enables us to have a completely clean backside to the machine, which enables us to put another machine in very close proximity to it, maximising the output from the floor space.
So you could flip this machine around again and
Yeah.
nest it in right
Yeah.
here. And
So-
in this room, you could probably fit, I don't know, another 10, 12 of these then just in this little space.
Yeah, well, I think it's around 10 machines to 80 square metres, so it's a very high output from that machine, that floor space.
So you're talking about a real density of engineering capacity.
Yeah, I mean, if you look at this machine and compare it to an alternative brand, then you could potentially get two machines in the same footprint as the single spindle machine elsewhere.
So I know that your 4mm and your 7mm Swiss Nanos are very popular.
Mm-hmm.
Why do you need a 10mm?
So it's market driven, as most things are generally. This gives us obviously the bigger bar capacity and also the longer lengths. Primarily, a lot of the demand has come from medical sector for bone screws and that type of equipment, but obviously there's other markets as well that increase in capacity will benefit.
If someone's looked at your 4 and your 7 and thought, well, my parts are a little bit longer than that, what is the actual length for the 10 here?
So on here it's 100mm maximum stroke.
Right,
So-
okay, which is pretty, because I guess you need to take the bush out, you need to put the bush in to
Yeah.
achieve those lengths. But
Yeah.
you can also use this bushless as well.
Yes.
So again, it's all about the options on the front, the options at the back,
Yeah.
for getting the absolute smallest cycle time for that part.
Yeah, exactly. Yeah, and yeah, as you say, bushless running up to 2.5 to 3 times diameter.
Brilliant. For high volume parts and machines you can trust, get in touch with David Dunn from Premier Machine Tools. Check out the Tornos Swiss Nano 10, brand new machine.